Good morning to everyone. Myself T. Muthukumar, Assistant Professor, Kongonadu College of Engineering and Technology. Today, I am going to deliver a lecture on testing of isolators and circuit breakers in high voltage engineering subject. This is one of the important topic in high voltage engineering. First of all, why we need for test the high voltage equipment? So it is ensured that the electrical equipment is capable of withstanding the over voltages that are met within service. So we are going to test the high voltage equipments. So it is able to withstand the over voltages in over voltage conditions. The over voltages may be either due to the natural causes like lightning or system originated ones such as switching or power frequency transient over voltages. Hence, the testing for over voltages is necessary for all the high voltage equipments. So our aim is to check the or to ensure the electrical equipment is capable of withstanding the over voltage or not. The over voltages are lightning over voltage or switching over voltage or power frequency over voltage. So we are going to apply these type of voltages for the test equipment and finally verify these are capable of handling this or withstanding these over voltages or not. That is the need for testing of over voltages. So comes to our topic, the testing of isolators and circuit breakers. So isolator is a disconnector, is a mechanical switching device which provides in the open position. So it is a mechanical switching device which provides in the open position. An isolator is capable of opening and closing the circuit when either negligible current is broken or made or when no significant change in the voltage across the terminals of each of the poles of the isolator. So it is capable of opening or closing a switch when either negligible circuit is broken or made or when no significant change in the over voltage across the terminals. So it is also capable of carrying the currents under normal circuit conditions and carrying for a specified time currents under the abnormal conditions such as those of short circuit. So it is capable of carrying the current under normal conditions. So and also under the abnormal conditions. So main function of circuit breaker is making or closing the electrical circuit. It is a mechanical switching device. So testing of the breakers is intended to evaluate the following characteristics. So it is used to evaluate the constructional and operational characteristics, also its electrical characteristics. So the different characteristics of the circuit breaker can be listed below. The electric characteristics which is used to determine the arcing voltage. So with the help of the testing, we are able to find out these following electrical characteristics. That is arcing voltage, the current chopping characteristics, the residual current, the rate of decrease of conductance of the arc space and the plasma, and the shunting effect in interruption. So these following characteristics will be determined by the electrical characteristics under the testing. Other physical characteristics are the pressure developed or impressed at the point of interruption, the speed of the contact level, the number of breaks, the size of the arcing chamfer, and the materials and the configuration of the circuit interruption. So these physical parameters are also going to test or determine during the short circuit and testing of circuit breakers. So other characteristics are electrical loading, the normal generated or applied voltage, the type of fault in the system which the breaker has to clear, the time of interruption, the time constant, the natural frequency and the power factor of the circuit, the rate of rise of recovery voltage, the restricting voltage, the decrease of the AC component of the short circuit current, degree of asymmetric and the DC component of the short circuit current. So these characteristics are also going to determine with the help of testing of isolators and the circuit breakers. The major testing or main test conducted on the circuit breakers and isolators switches are dielectric switches. So dielectric test or over voltage test. So second method is temperature rise test. Third one is mechanical test. Fourth one is short circuit test. These are the very important tests to be carried out on the circuit breaker and the isolators. So dielectric test or over voltage test. Second one is temperature rise test. Third one is mechanical test. Fourth one is short circuit test. So first we are going to discuss dielectric test. So it consists of over voltages, withstand test of power frequency, lightning, and switching impulse voltages. So three different voltages we are going to apply for the equipment, and we are going to test these are the our equipment capable to withstand these voltages or not. We are going to verify. So one is power frequency over voltage, another one is lightning over voltage, another one is switching impulse voltages. The tests are done for both internal and external installations with the switch or circuit breaker in both open and closed position. So we are going to done this test in both open and closed position, also both internal and external installation conditions. So in the open position, the test voltage levels are 15% higher than the test voltage used when the breaker is closed position. So we are going to use the 15% higher voltage for testing the circuit breaker in the open position compared to the closed position. So there is always possibility of line to ground crossover will be possible during this test. So to avoid this, the circuit breaker is mounted on the insulator above the ground. So we are going to mount the circuit breaker above the insulator. So it is possible to increase the insulation level of the body of the circuit breaker. It will be raised. So with the help of this arrangement, insulation level of the circuit breaker will be raised. So this is the dielectric test. So we are going to apply over voltage to the circuit both open and closed conditions, and also both internal and external installation conditions. So next one is temperature rise and mechanical test. So temperature test. So we are going to apply the rated current continuously for long period. So we are going to apply the rated current for long duration. The temperature readings are taken by using the thermocouple. With the help of thermocouple, we are going to measure the temperature. So if the temperature is within the specified value, means our equipment will be clear that is the switch gear will clear the test. So otherwise it is failed to clear the test. So in mechanical test, the circuit breaker and isolator must open and close at a correct speed and perform operations without mechanical failures. So we are going to verify the mechanical switch is closed or open in correct speed, or any mechanical failures is available or not. So this test can be carried out by the mechanical test. So next one is impulse test. The lightning impulse wave of standard shape are done in a similar manner in the case of insulator. So we are going to provide the standard impulse voltage as a test voltage. So we are going to apply the impulse test voltage, so and verify this voltage is capable by the our circuit breaker or not. So in addition, the switching surges test with the switching over voltages are done on circuit breaker and isolator to assess their performance under over voltage due to the switching operation. We are also going to apply the switching over voltage to the circuit breaker and going to test the ability. So next is short circuit test of isolators and circuit breaker. This is a very important test of circuit breaker and isolator, because it is used to assess the primary performance of the devices. That is the ability to safely interrupt the fault currents. We are able to safely interrupt the fault current or not. We are going to verify this, determine this short circuit test. So this consists of determining the making and breaking capacity at the various load currents and rated voltages by applying the different load currents and different load current conditions, and determining the making and breaking capacities of the circuit breaker. So it is called short circuit test. So in case of isolators, the short circuit tests are conducted only with a limited purpose to determine their capacity to carry the rated short circuit current for a given duration. So we are going to test the or use this short circuit test to determine the capability of carrying the rated short circuit current for a given duration. Here, no breaking or making current test is done. So only we are going to check the capacity to carry the rated short circuit current for a given duration. This is the aim of the short circuit test. So we are not going to test the making and breaking current test. So different methods of conducting short circuit test are, there are two types. One is direct test, another one is synthetic test. So direct test means, so using the short circuit generator as a source, we are going to use the short circuit generator as a source, and then only we are going to test. So second one is using the power utility system or network as the source. We are going to use the network, power utility system or network as a source. So we are going to test directly with the short circuit sources. So second one is synthetic test. So synthetic test, the direct testing in the networks or in the fields. So we are going to test the circuit breaker in the network or in the field directly. So circuit breaker are sometimes tested for their ability to make or break the circuit under normal load conditions or under short circuit conditions in the network itself. So we are going to test the equipment under normal load conditions or under short circuit condition in the network itself. So this is the short circuit testing in the networks or fields. So this is done during the period of limited energy consumption. So we are able to conduct this test during the limited energy consumption or when the electrical energy is diverted to other sections of the network or not connected to the circuit under test. So only we are going to conduct the minimum energy consumption conditions. So advantages of the field test. So if you test the circuit breaker in direct field means, so we have the advantages. The circuit breaker is tested under actual conditions like those that occur in a given area. So actually we are connecting the, actually we are going to test the conditions. So second one is the special occasions like breaking of charging currents of long lines, breaking of charging currents of long lines, very short line faults, interruption of small inductive currents, etc. can be tested by direct testing only. So we are going to test these conditions only, direct testing method only. So breaking of charging currents for long lines, very short line faults, interruption of small inductive currents. So these conditions can be tested by only direct test. So to next, to assess the thermal and dynamic effects of short circuit current, to study applications of safety devices, and to revise the performance test procedures. So for this purpose, these are the advantages of field test. So the disadvantage, the circuit breaker can be tested at only a given rated voltage and network capacity. So able to test only given rating only. So not able to test other than conditions. So the necessity to interrupt the normal services and to test only at light load conditions. So we are during the test time we need to interrupt the normal services. So and we are going to test only light load conditions. This is one of the drawback. So extra inconvenience and expenses in installation of controlling and measuring equipment will be happen. So expense cost will be increased and also inconvenience will be available for the installation time. So next, direct testing in short circuit laboratory. So in order to test the short circuit breakers at different voltages at different short circuit currents, short circuit laboratories are provided. So short circuit laboratories are available. So in short circuit laboratories, we are going to test the short circuit, that is circuit breaker and isolator with the different voltages at a different short circuit current. So with the different short circuit current, we are able to test only in short circuit laboratory. So it consists of short circuit generator, short circuit testing generator, backup breaker, that is a master breaker, reactor, making switch, test device, and some measuring devices. So it is the combination of all the equipment. So it consists of short circuit generator in association with master circuit breaker, that is called backup breaker, resistors, reactors, measuring devices. We are using the current or shunt transformers. So here a making switch initiate the short circuit and the master circuit breaker isolates the test device from the source. Here making circuit is closed means, so initiate the short circuit test, and the master circuit breaks the circuit breaker and isolates this test device from the source at the end of the predetermined time set on your test sequence controller. Also, the master circuit breaker can be tripped. This master circuit breaker can be tripped if the test voltage device failed to operate properly. If the test device is failed to operate properly, means automatically the master breaker protect the circuit. So short circuit generators with induction motors as prime movers are also available. Next one is synthetic testing of circuit breaker. So due to very high interrupting capacities of circuit breakers, so circuit breaker having very high interrupting capacities, so it is not economical to have a single source to provide the required short circuit and rated voltage. So it is not possible to provide a required short circuit and rated voltage with a single source. So it is not economical. So we are going for the combination of two sources. Hence, the effect of short circuit is obtained as regarded to the intensity of the current and the recovery voltage as the combination of the effect of two sources. We are going to produce the short circuit current with the help of two sources. So one is providing the current, another one is providing the voltage. So one of which supplies the AC current and the other the high voltage. In the initial period of the short circuit test, the AC current source supplies the heavy current at a low voltage. So initial time of short circuit test, AC current source supplies the heavy current at a low voltage, and then recovery voltage is simulated by a source of comparatively high voltage of small current capacity. So one source provides heavy current with low voltage, other source provides heavy current, that is heavy voltage with low current, that is small capacity current. So this is the schematic of synthetic testing station. So VC is called low voltage high current generator. VC is called low voltage high current generator. So LC current controlling inductance. LC is the current controlling inductance. One, that is switch 1 is called master breaker. So 3 is called main switch. 3 is called main switch. T is the circuit breaker under test. T is the circuit breaker under test. Number 4 is the auxiliary breaker. So 1 is the main master breaker or main breaker. 4 is the auxiliary breaker. So LV, voltage waveform controlling choke. This is the voltage waveform controlling choke. 6 is the trigger cap. CV is charged to EV to give necessary recovery voltage. C0 capacitor to control the frequency of the transient recovery voltage. So transient recovery voltage. So VC, low voltage high current generator. This is one of the source. This is battery. This is E, one of the source. That is CV. Capacitor charger to EV give necessary recovery voltage. This gives the current. This gives the voltage. So the combination of the two sources, we are going to provide the short circuit at the rated level. So with the auxiliary breaker 4, here auxiliary breaker 4 and test breaker T is closed. So 4 and T will be closed means the making switch 3 causes the current to flow in this test circuit breaker. So with the auxiliary breaker 4 and test breaker T is closed means the making switch 3 causes the current to flow in the test circuit breaker. At some instant time T0, the test circuit breaker begins to operate and the master circuit breaker 1 becomes ready to clear the generator circuit. At a time T is equal to T0, the test circuit breaker begins to operate and master circuit 1 becomes ready to clear the generator circuit. At some times T1, just before closing the generator current, that is just before the zero of the generator current, the trigger gap 6 closes and high frequency current from discharging capacitor CV also flows through the arc. So at T is equal to 0, the circuit breaker T and breaker, that is auxiliary breaker 4 will be the closed. So 3 makes a current flow through the circuit breaker. So at T1, before the zero of the generated current, the trigger gap will be triggered, and higher frequency current from the discharging capacitor CV also flows through the arc. At the time T2, when the generator current is zero, at the time 2, the generator current is zero, the circuit breaker 1 clears the circuit. That closes that is open the circuit. So leaving only the current from CV, which has the required rate of change of current as it zero flowing in the test circuit breaker. So after some time, so only current is flowing only through the CV. So at zero of this current, the full test voltage is applied. The current voltage is zero means full test voltage is applied. So with the help of VC and with the help of CV, we are going to provide the rated short circuit voltage. Initially, VC provides the current. So after triggering the trigger switch 6, CV supplies the current to the testing circuit breaker. So finally, only current through the testing circuit breaker will be possible. So if this current will be goes to zero means, so total voltage, that is high rated voltage applied across the test circuit breaker. So next one is composite testing. So in this method, the breaker is first tested for its rated breaking capacity at a reduced value. So we are going to test the rated breaking capacity at reduced voltage after sometimes for rated voltage at low current. So we are going to test the rated breaking capacity at a reduced voltage at initially, after sometimes for rated voltage at a low current. So this method does not give proper estimate of the breaker, does not give proper estimate of the circuit breaker performance. So your next method is unit testing. When a large circuit breakers of very high voltage rating 220 kV and above are to be tested, and where more than one break is provided per pole. So we are going to test very large rating circuit breaker. So more than one break is provided per pole. The breaker is tested for one break as it is rated current and estimated voltage. So breaker only tested for one break as it rated current and estimated voltage. So at the rated condition, rated current and the rated voltage condition, the breaker is tested for only one break. So this is called unit testing. So next one is asymmetrical test. One test cycle is repeated for the asymmetrical braking. One cycle is repeated for asymmetrical braking capacity, in which the DC component at the instant of contact separation is not less than the 50% AC component. So DC component is not less than the 50% of the AC component. So these are the under the short circuit test, composite testing, unit testing, and asymmetrical testing. So finally, I'm going to conclude this lecture with a small recap. So need for the testing of our voltages. So we need to test the or ensure the equipment is capable to withstand the over voltages or not. That is our aim. The natural over voltage, that is lightning switching over voltage, power frequency over voltages are the causes of over voltages. Testing of isolators and circuit breakers. So isolator means it is a disconnector, it is a mechanical switch which provides the closing and open positions. Also carries the current during the normal conditions and also during the short circuit conditions. So it is used to avoid the electrical characteristics, constructional and operating characteristics of the equipment. The tests are dielectric test or over voltage test, temperature rise test, mechanical test, and short circuit test. So dielectric test, so we are going to apply the power frequency, lightning or switching impulse voltages to the directly to the equipment. It is able to withstand means the circuit breaker will be clear the test, otherwise it is failure. So second one is the temperature rise and mechanical test. We are giving the rated current continuously for long duration, and the temperature is reached by the thermocouple. If the temperature is specified level means then the switchgear is said to be was passed the test, otherwise fail the test. So mechanical test. So we are going to check the open and close at the correct speed of the equipments and perform the operations without mechanical failure. Impulse test. So we are going to give the standard impulse voltage to the testing equipment. So and check it is able to withstand or not. Short circuit test, very important test of circuit breakers to assess the primary performance of these devices. That is, it is easier to determine the making and breaking capacities at various load currents and rated the voltage. Two types of tests are there. One is a direct test, another one is indirect synthetic test. So direct test, so use a short circuit generator as the source, other power or utility system used as the source. Synthetic test. Synthetic test, the networks are in the field. We are going to directly test the equipment in the network itself or in the field. So there are some advantage and some few disadvantage also. So next one is direct testing in short circuit laboratory. So with the help of short circuit laboratory, we are going to apply different short circuit current to the equipment and finally testing. Synthetic testing of circuit breaker. So single source of is not enough to produce the required or rated voltage of short circuit current. So we are going to use the combination of two sources. One source provide the high voltage with low current. Another one is low voltage with a high current. So combination of these two sources, we are able to provide the rated short circuit voltage. So here the VC gives the, that is the auxiliary switch 4 and T is closed mean making switch provides the current supply to the testing circuit breaker at the initial conditions at T equal to T1 before closing of the zero current. So trigger gap 6 will be closed. So capacitor CV supplies the current to the trigger testing equipment. So finally, so it capacitor CV only supplies the short circuit current. So this is the combination of both the sources. So composite testing. So here we are going to test the rated braking at low voltage level and then rated value. So unit testing means we are going to test the breaker is tested for one brake at its rated current and the estimated voltage. One brake. Asymmetrical test. So is repeated for one cycle is repeated for the asymmetrical braking capacity in which the DC component at the instant of contact separation is not less than 50% of the AC component. So with the help of this test, so we are able to determine the electrical and physical and also performance characteristics of circuit breaker and isolators effectively. Thank you.